Alright, welcome back. So for today, we are going to be doing path making, which will get us the ability to get the object moving in a circle for now, and then afterwards we're going to use that for our idle. Once idle is done, then we can do the other things. So what I made was I got a node called Pathmaker, just as path, and I have like 4 dummy nodes that I'm using as points. Now you'll notice one thing. I wanted to make a clockwise, an anti-clockwise rotation, so moving in reverse of the clock, and you'll notice that the object's green is pointing to the next object that we wanted to point at. So to make the path, we actually made a code and we called it a path maker. We just have a node object, time between points, and path points, and then we have 3 privates, and then we have 2 functions, and we're going to be using this soon. So the first thing we're going to say is I have path points, basically points between, or like I want to make a path between these points, and they're just chilling here. And it's very important to notice that the point's green arrow, so the forward, is pointing to the next point that we want to go to. So that's one of the main things that we got to do, and I just made it part of a child for this just so I can collapse it and make it cleaner to look at. So anyways, we connected those. Here we have the object to move, which is our enemy right here, and then we have the path between points, the time it takes to go from point number 0 to 1 to 2, 3, 0, and then keep going over and over again. Okay, so we got that. So what we're going to do now is we're going to start the coding. So we're going to be using our regular weighted coding and our num coding, and we're going to be using a path. Path is a spline graph. If we go inside here, inside here, we got spline graphs, which basically creates a calculated smooth curve using start and tangents with the up direction. So we're going to do all that. You can read more over here if you want, but let's start it. So first things first, we're going to initialize path. So path equals to new, and just put circle brackets, and we're good. The next thing we're going to do is we're going to add these points. So 4, and we're just going to add int I equals to 0. I is less than the path points, so the ones that we chose, right? Dot count, how much there are, and then I plus plus, just increment it once, and we're just going to do a simple path dot add point. It's going to ask us the point, so we're going to do path points I dot world position, and that's it. So now we have these points, and we captured their world position. So the next thing we're going to do is we're going to add a segment, and over here, since we got the points, now we're going to add the line between it, we're going to add the tangent, and we're going to add the up vector. So the tangent is the direction where we want the line to bend. Alright, it's all Bezier curve mathing, but we're going to just do a simple 90-degree bend, which will just give it a constant, and for the up, we're just going to use up so it can calculate the direction. So what we're going to do is path dot add segment. Then when we go in, we actually have a few things. We got the start index, tangent up, and index tangent up. So point number 0, point number 1, they're tangents and they're ups. So we're gonna use, we're just gonna hard code it for now, just so you guys can understand. Then for path points dot get direction, path point 0, because we're using 0. Okay, then we're gonna get world direction. We're getting its forward vector, and the reason why we're going to use the forward vector is just so you'll understand like the simplistic way of doing this. So axis y, we're going to do axis y, and then the start up is going to be path points 0, and then dot get world direction, and we're going to do axis z. Okay, so that's our first segment, and we're gonna now press comma, press enter, just a new line, and we're just gonna use 1 comma and then copy and paste this whole thing, because we're gonna take the same point. We're gonna take the next point in the list, which is number 1. Let's just do number 1, and instead of the tangent being y, we're gonna take ny. Now if you look here, because where we made all of them face forward, right? So we're gonna have the tangent end, which is the reverse, which is ny. So over here we're just gonna add ny, and the forward up direction would be the same. Okay, so we did that. Now we're gonna do it for all the points, and if you do it procedurally or like with a for loop, that's all good. I'm just gonna hard code this, and we're gonna change the values. So this one's going to be 1 to 2, this one's going to be 2 to 3, this one's going to be 3 to 0, and then change the rest of the numbers too. So the reason why we made it from 3 to 0 is because we're making a loop. So it goes from 0, 1, 2, 2 to 3, 3 to 0. So it goes in a circle. Now this is only if you wanted a loop. If you don't, there's no reason to use it. That's all good. Okay, the next thing we're going to do is actually render this so we can actually see these things. And we're going to do both. We're going to render it, and we're actually going to write the code to move it. But first, let's render it. And to render this, what we need is, you guessed it, a for loop. We're not going to copy and paste this all the time. So we're going to use this, and then we're going to do path.numPoints for the length, which is the number of points that we have. Then we're just going to do a visualizer.render point 3D, and then we're going to render path.get point I as our vector, size as 0.1f, and vector 4.red. Actually, let's just do black for this. Okay, so that gets us our points, our render. Next, we're going to get our tangents and our vectors. So now we can see the arrows of where they're pointing. This way you can actually calculate it if you know your math. If you don't, I suggest looking it up. There's a good video by Freya talking about Bezier curves. You can learn a lot from there. I'll link that up too. But for now, what we have is a vector 3 starting point. I'm going to do comma, space, starting tangent, tang, I'm just going to use tang, end point, and end tang. Let's just use capital T, capital P, capital P. And they're all going to call from path. So we're going to just do path dot calculate, get segment starting point, and then it's going to choose the index number 1. And it's going to be path.get segment starting vector tangent, sorry. And then for these, it's going to be path.get segment end point number I. And then for this, it's going to be path.get segment end tangent I. So now we got that. Let's just visualize this. Visualizer.render vector, and then I'm going to choose position, s point, right, and then s point plus s tangent. Right, so the position plus the movement, and then it's going to ask for color. So vector 4 dot, I'm going to choose green for this. This is the front vector, and we're just going to copy paste it, and then we're going to change this to endpoint plus end vector, and we're going to change this to red so we can see the reverse. Okay, so that's done. We're going to add one more for loop inside the for loop. Yes, a 4 inside a 4. Now it's highlighting over the I. Just press J and press tab. It's going to change all of them to J. And then for this word length, we're going to change it to segments. You can make a number up here to choose how many segments you want, but I think 50 is a bit too much / good enough. So for segments, we're going to do a vector 3.0 and a vector 3.1. And for vector 3.0, we're going to do path.calculate segment point, and then it's going to choose index, we're going to choose I, and then the float or the time we're going to choose within these segments. So we're going to take J, which is our segment size, and then we're going to choose segment, the total segment. So that's going to give us that, and then we do path dot same thing I, and then in this case we'll do J plus 1, right, divided by segments. So we're going to take from point and the point after, giving us perfection right there, and then we're just going to draw a line. So visualizer, render line 3D, and then we're going to render from point 0 to point 1, and then vector 4 dot white. So that gives us all our visualization, and we could press play and see it now since we have it on our update, but let's actually add everything into this. So let's just do wait equals to mathlib dot clamp. So wait plus equals, and then in brackets game dot time, IFPS, all right, and then divided by the time between points. So time between points, press a comma, 0.0f, 1.0f. So this means we're clamping the wait between 0 and 1. It's going at a rate of 1 second. So it's going to turn 0 to 1, or start to end, in 1 second. And then the time between points is the division between how long you want it. So 1 second divided by 5, meaning 5 seconds. And then we're going to have it 5 times slower. That's 5 seconds. And then it's going to take 5 seconds to get from 0 to 1, which is our ratio. Okay, I'm saying that too many times. Okay, so once we do that, let's immediately calculate the fact that if wait equals to 1.0f, so the moment it gets to 1.00f, let's reset the wait, and then num plus plus, so we go up a number. And then what we're gonna do is the num, we modulus operand it with the path.num points, so the amount of points, so we can reset between 0, 1, 2, 3, and then just keep going in a circle in these points. So with that done, what we're gonna do is object to move dot, actually before we do that, let's do a vector 3, and we're just gonna add points, comma, direction, and up vector. All right, actually let's just do point direct up vec. Okay, cool. So it's going to be path dot calculate. So now we're going to calculate the points, the tangent, and the up vector, and we're going to use the index as our num and the float as our weight. So that gives us that. Then path dot calculate the tangent, use the same values, and then for up vector dot calculate up vector, num, weight, and with that calculated, now we can actually get the object to move dot world position equals to point. All right, object to move dot world direction, right, and that's going to ask us for the thing, so direction, and then up vec, and then for the axis we're going to use axis y, because of the way we made the thing follow. So with that, let's just press play. So as we're here, we can see the arrows. All right, we got the green facing there, then the green facing there, it's gonna move there, then this green is facing to that point, so now it's gonna move to that point, and then as it's going, you can see it's not going in a straight line, there is a little curve, and that's the tangent movement, but it's going in that direction. So we got that movement going in, and it's moving in a perfect patrolling direction. So now what we're gonna do for next episode is implement oops. What we're gonna do for next episode is implement the thing into our idle AI state, and once we get it into idle state, if we get alerted, he's gonna stare at us. After a while, if he couldn't get anybody, then we go back to idle, and then we're gonna just change a few things. So if he's not inside Frustum, we're gonna drop the weight until it's 0, and then once it's 0, then we go back to idle and stuff like that. So we're gonna do that for next episode. Until next time, I will see you again. Goodbye.